So good morning to Ikmal and also Diza. So welcome back. We have covered the straight line and also reducing balance method in our previous class, previous session, synchronous session. And today I would like to tackle the third method that is a bit more mathematical, which is on the topic of the sum of the years digits method. Normally, it is also known as the SYD method. Yeah.
Sir, it sounds complicated, sir. What does it mean?
SYD is a method that accelerates depreciation. Okay, more in early years, less in later ones. Basically, it uses fractions based on a number of years, the asset's useful life. So let me just give you the formula for the SYD. The depreciation you can take down, or you can also refer to the same, but never mind, just take it down. Depreciation for a year is equals to remaining life divided by sum of the years digits, total of the years digits, sum of the years digits multiplied by open bracket cost minus the scrap value, or cost minus the residual value. Can you hear me?
Yes, can.
Yeah. You got the idea?
Yes.
Do you know what do you mean by sum of the years digits?
Sum of the years digit
Okay,
means
let's
that.
say the useful life is 5 years. You will add all the digits from 1 to 5. Therefore,
Mm,
you'll be getting about 1 plus 2 plus 3 plus 4 plus 5, you'll be getting about 15. Yeah, you'll be getting about 15. So that's
mm.
the denominator for each year's fraction. Use each year's fraction. Got it? So now let me just give you an example. Example of asset depreciation. Asset depreciation using the sum of years digit. Sum of years digit. Maybe I can give you a question here. Let's say a delivery van. Okay, you can take it down. Example here. Let's say a delivery van cost about 40,000. The cost of a delivery van is about 40,000, and let's say it has got a residual value of 10,000. Okay, a residual value or scrap value, or a salvage value, also known as a salvage value of 10,000, and maybe a useful life of about 5 years. Okay, now let's find the depreciation for each year using the SYD method. Yeah. So now, Lisa, can you try to calculate?
The first total depreciation would be 40,000 minus the 10,000 is 30,000.
Exactly. Now let's find the depreciation for each year. Okay, this is the total depreciation is 30,000. Now let us calculate for the yearly basis. In year one, we can see the year one remaining life is about 5 years. So the fraction is 5 over 15. Okay, 5 over 15. And then why 5 over 15 is because of the sum. You can see just now we did the sum where we take the first year plus second year plus third year plus fourth year plus fifth year. So 1 plus 2, 2, 1 plus 2, 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Yeah. So the fraction will be 5 out of 15. So the depreciation using the formula is 5 over 15 times the 30,000, which is the total depreciation. The total depreciation basically we take by taking 40,000 minus the 10,000. Yeah. So therefore, the first year depreciation you'll be getting is 10,000. Are you getting it?
Yes.
Yeah. So for the same thing for the year two, the remaining life is not 5. Year two, the remaining life is 4.
4.
So we reduce 1. So the remaining life is 4. 4 years divided by the sum of what? Total years. Sum of total years. So that is what we say the sum of the years digit. So sum of the year digit is 15 already, 5 years. So 4 divided by 15 times with the 30,000, same total depreciation, 30,000. So 4 over 15 times 30,000, how much do you be getting? 8,000. You'll be
8,000.
getting, yeah, 8,000. Yeah. So now let us go for the year 3. If we look at the year 3, so it's going to be the remaining life is going to be 3 more years to go. The current year, the year 4, and also year 5. The remaining year 3 years to go. So 3 year divided by the sum of the total years, sum of the total years digits. So you'll be getting about the 3 divided by remaining life year, remaining year divided by the sum of the total years. So we are doing 3 over 15 multiplied by the 30,000 again. So we're getting about 6,000 there. Getting about 6,000. So year 4, Adiza, can you try?
Year 4 will be 2.
Remaining, yeah. Remaining life will be 2 years.
Remaining life will be 2 years. Then divided by 15 will be the depreciation will be 4,000.
Yeah, the 2 divided by 15 times with the 30,000. So we're getting about 4,000. Yeah, 4,000. So same goes for the Ikmal. Would you like to give it a try? So maybe let me just quickly tell you the answer. Year 5 is that 1 more year. The last year is the remaining life will be 1 more year to go. So 1 divided by the sum of the total years will be 15 times with the same total depreciation, which is what? 40,000 minus the 10,000. 10,000 is the residual value. So we're getting 30,000. So the 1 over 15 times the 30,000, you'll be getting about 2,000. 2,000.
So sir, the total still adds up to 30,000.
Absolutely. So you take the depreciation for year 1, year 2, year 3, year 4, year 5. So you must get the same total depreciation. So the total depreciation has been segregated to 5 years, but not equally like what they have seen in the straight line balance method. So now the question here is, what you have to understand now is why we use the SYD approach. Why we use the sum of years digits approach. So SYD, the sum of years digits method is useful when an asset loses value quickly at first year, but slower later. Okay, thinking like, for example, vehicles or high technology devices. Okay, so now let me just talk to you about the features and also the sum of years digits method here, the approach here. So the depreciation pattern of the SYD approach, okay, is accelerated but declining fast. Depreciation pattern. If you look at the difference, it is not constant like SLM. Straight line method is accelerated but declining, fast decline the first year, then slower. And if you look at the early year expense, is higher. Okay, the first year, the beginning of the year's spending on the depreciation is greater. Complexity is a little medium, and it is best used for the cars, computers, or technological years. So now let me just throw a student practice to you all. So maybe you can give a try. Maybe you can take down, please take down as I say. Let me see your level of understanding. Let me check on your level of understanding through the conversation. Okay, now let's say we can take down the important points and you can perform the calculation. Okay, maybe a laptop. Take note, both of you, Riza and Ikma. A laptop cost 12,000. Let's say a laptop cost 12,000. And let's say I give you the residual value or a scrap value, residual value about 2,000 ringgit, 2,000 ringgit. Laptop 12 ringgit, 12,000. Residual value or scrap value there, 2,000 ringgit. So now, let me just give you the useful. Let's say the useful life. We are using the laptop. Let's say for 4 years. For 4 years. Can you calculate the total depreciation and the sum of years?
Total depreciation will be 2,000 minus 12,000 minus 2,000 will be 10,000, and the sum of years is 1 plus 2 plus 3 plus 4 will be 10 years.
Yeah. So you see the total depreciation just taking the what we call that is the cost of the machine or the laptop divide minus the residual value, you'll be getting about 10,000. And the sum of the years is just 4 tahun, satu campur 4 tu first year, second year, third year, fourth year. So satu
Yeah.
campur 2, campur 3, campur 4. So we'll be getting about 7, 10 years. So 10 years.
10 years.
So what about the yearly calculation? Who can do?
Okay, for yearly calculation, so
You
4
can take your
years,
time. You can take your time.
4 years divided by 10 years
Mhm.
times 10,000 will be 4,000. Then 3 years divided by 10 years multiplied by 10,000 will be 3,000. 2 years divided by 10 years multiplied by 10,000 will be 2,000. Then 1 year remaining divided by 10 years multiplied by 10,000 will be 1,000. So 4,000 plus 3,000 plus 2,000 plus 1,000 will be 10,000.
Exactly. Perfect. You have mastered. You have mastered, literally, you have mastered SYD. So good. Right. So now, let me just compare the methods here. So we discussed about the straight line method. We discussed about the reducing balance method, and also we discussed about the sum of years digits method. Yeah. So you can see the year one depreciation. The year one depreciation can be much same year. The pattern is the same for the every year. The pattern for straight line, but for the reducing balance method, it's fast, then it slows. But the complexity we can say it's easy. No complexity for the straight line method is very direct. But for the reducing balance, medium. But if you look at the SYD, you can say it is a bit fastest. It is the fastest in the beginning, and the complexity we can see is quite medium. Okay, so the year one depreciation, let's say straight line method is 2,500. So the reducing balance can be more than that, must be more than that for your kind of information. For example, let's say the reducing balance method, the first year depreciation can be 3,000. 2,500 for straight line, 3,000 for reducing balance. But if you see, if you calculate the SYD, it must be greater than the reducing balance for that for sure, because it should fall greater compared to the reducing balance method. So maybe about 4,000 or greater. So now let us just look at the wrap up challenge. I would like to throw some questions to both of you. Maybe, okay, let me just give you the challenge. You can jot down some important information. Maybe I can say an asset cost about 30,000 with a 5,000 residual value for 3 years, 3-year useful life, 3-year useful life. Now, use the SYD approach, the sum of years digits approach to calculate the total. First, you calculate the total depreciation. The second, please calculate the depreciation for you. Maybe you can use this for your homework.
Okay.
Okay. All right. So now I think we should go for the units of production method, the other approach. You have seen the SLM, reducing balance, some SYD, sum of the years digits. So now we will be exploring into the units of production method, a very logical way to calculate the depreciation, in my view. So Lisa, would you like to guess it?
Okay, let me guess. It depends on how much we use the asset.
Exactly, Lisa. This method bases depreciation on actual usage rather than time. So now let me just explain what is the units of production method. So some assets wear out based on how much work they do, not just how long they have been around. Okay, how much they have produced, or how much they have contributed. In other words, so not the useful life, how long they were there. See, there are two perspectives. So you got a machine. If you're not using, but still it is depreciating. But actually, no, it is not depreciating. That's the argument here. Some we have to use them in order to for the value to depreciate. You buy a car and then you didn't use the car, then it means the value. It's everything is the same thing. Anyways, so think of a printing machine, a vehicle, or a factory robot.
So, sir, a truck that drive more miles loses value faster, is it?
Yes, yes, yes. You're totally correct. So that's why companies normally prefer this method for equipment used at varying rates. Now, let me just give you the formula, right? The formula for you to take down. Uh, so for us to easily calculate it. So now for the formula is depreciation. Take down depreciation. DEPRECIATION. Depreciation per unit. UNIT. Depreciation per unit equals to uh, cost minus the residual value. Cost minus the residual value. You can put them as a numerator, number atas. It is a fraction. Numerator is what cost minus the residual value. Basically, cost minus the residual value, it is the total depreciation. So divided by the estimated total units of production. Okay, estimated total. So that is for the depreciation per unit. And then for each year, you can take it down, take down depreciation expense. Depreciation expense equals to the depreciation per unit multiplied by units produced in the year. I remember that I was showing you guys all the formulas in our previous session.
Yes.
Yeah, I was showing the formulas in the sim. So these two formulas here. So now let me just, with this formula, let me see whether you can calculate the depreciation or not. So let me just give you an example. Machine depreciation by usage. Machine depreciation. Um, Let me think about an example, some values. Okay, let's say a company buys a machine. Let's say your company lah, you got a company and you are buying a machine. Let's say you spend about 50,000, 50,000, 50,000. You're expecting the machine to produce around 100,000 units during its lifetime. Okay. And let's say you need a residual value, by the way. So let's say the residual value is about 10,000.
So, sir, the total depreciation will be 50,000 minus the 10,000. Means that
Yeah.
40,000.
Yes, 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 yes. So as usual, the cost minus the is residual value, 40,000, correct. So the depreciation per unit will be 40,000. It's a bahagi with the production expected production units. The expected production unit will be 100,000. 100,000. Therefore, you can see 40,000 bahagi 100,000 unit. So you'll be getting about 0.4 lah. Okay, you can try to calculate. See, let me check the value. 40,000 divided by
Yes, it's 40
1,000.
cents.
So how much you get?
40 cents. 0.4.
0.4. So if the machine, okay, so now if the machine produce yearly, let's say we can break it like this, 100,000. Maybe we can break it like this. Year 1, year 2. I said 4 years, right? 4 years. Year 1, year 2, year 3, and year 4. So let's say we try to, let me just try to spread that 100,000 in 4 years, maybe we can do the calculation for you. Maybe you also can calculate, and myself will calculate that. Let's say for the year one, out of 100,000, 20 ribu lah, let's say 20,000 were produced using the machine in the year one. 20,000, you can take down. Year one, you just write there, year one, Sengkang 20,000, the machine produced. Year two, Sengkang 30,000, 30,000. Year two, you put 30,000. So now it's 50,000 finished already. Balance, we got another 50,000. So year three, you put about 25,000. And year four, you put another 25,000. So now you can see year one, year two, year three, year four, and year five. We have about total of 100,000. So now what we do with this production unit, now let us calculate the yearly depreciation. Okay, can we calculate the yearly depreciation? So how we can calculate the yearly depreciation is we can calculate by taking the 20,000 times the 0.4, the depreciation per unit. So because the formula, the depreciation per unit is equals to the the yearly depreciation you can get by taking the output times the depreciation per unit. Okay, so for the year one, 20,000 times 0.4, we'll be getting about 8,000.
8,000.
Yeah. So we go for year two. Year two, I said about
50,000.
Yes, 30,000 times 0.4, we'll be getting about 12,000. Year three is about 25,000 times 0.4, you'll be getting about 10,000 and 10,000. Year three and year four, the same quantity, you see. So 10,000, 10,000. So therefore, the total depreciation, you're getting about 40,000. So you can see the total depreciation that we have already calculated earlier, matching with the units, Okay, okay, right. It's matching with the yearly unit. So we got about. Sorry.
So the machine wasn't used at all. So all in 1 year, so no depreciation.
Exactly. That's the uniqueness of this method. That's the beauty of the method. So when is this method used? So let me just tell you when normally we use, commonly used for machineries or vehicles, mileage base. The mileage base depreciation. See, when insurance or some other applications or some other valuation, they don't see the mileage, but normally they roughly look at the years. Years. So because mileage can be adjusted sometimes, but if you follow the proper mileage, so you can see that you can use this method. The machine mileage, vehicles mileage base, equipment used per job or per unit. So it is optimal when usage is not consistent every year. It is not consistent every year. So now let us just compare the methods. This method with the other method. So we have covered about the straight line method, reducing balance method, the sum of years method, and also units of production method. It's very interesting. Yeah. So depreciation basis, you can say the straight line is time. Reducing balance is also time, but declining rate. But but if you look at the sum of the years digit is also time based over time, but it is accelerated. So what am I talking about the time? Because whether you're using it or not, as long as the time passes, then we consider it is there's some depreciation value. Consider it is already old, it's there for some time and all that. But if you go by the units of production, it is based not on the time, it is based on the usage. How much the machine has been used for quantity of production or units of production. So it is let's look at the benefits. It is good for the method is good for. Okay, so for example, you see the equipment, machines and vehicles are good for the units of production, but machines with faster early wear is better to use the SYD approach. But electronics and cars, it is good for us to use the reducing balance method. And office furnitures and fittings, buildings and all that, it's good for us to use the buildings. You see, we cannot use the usage. We cannot use buildings for based on the time over time. So for furnitures we still can say based on usage. Our buildings we can use a straight line method. So now I think with this we can look at some practice question. So maybe I give you a question. Okay. Let's say a company buys a generator for about 24,000. Let's say they spend about 24,000. Can take down the value. So generator 24,000 with a residual value of 4,000. 4,000. Okay. So it is expected to run for 10,000 hours. Okay. And it's, let's say it is used for 2,000 hours in year one. So can someone calculate the depreciation per hour?
The depreciation per hour just now is 24,000 equal to, so is 4,000 ringgit divide to 4,000. 24,000 minus 4,000. I get 10,000, so 20,000 divided by 10,000 will be 2 ringgit per hour, sir.
Well done.
Then 2
Well done,
ringgit per
Lisa.
hour, so year one will be 2,000 times 2 is 4,000 for the first year.
Correct. Very good. Very good. Fantastic answer. So you're getting about 2,000 times 2, you're getting about 4,000 for the year one. That's correct answer. So what if estimates change? Okay.
So what if they later realize the machine can run more hours?
Sorry, can you repeat, Lisa?
What if later when the company realize the machine can run more hours?
More hours. Great questions. You see, businesses revise estimates if they have new information. Therefore, the depreciation per unit can change from point forward. Right. So now let us look at a final wrap up quiz. Before we take a short break, maybe we can take a short break for us to digest, for you guys to digest.
Okay.
Okay. So okay, final quiz wrap up. Maybe I can give you a question. Maybe about 4 questions. So what's the difference? If I ask you, what is the difference between or what is the uniqueness of the units of production method? Or how is it different?
Okay, it based on usage, not time.
Correct. Great. You got the point. Okay. Now, second question is, what happens if an asset was not used for a year?
Oh,
Based on
so
this approach.
there's no depreciation for the first year.
Correct. Good, good. Now, let me make it a little bit harder. If a car depreciates, you can take down. If a car depreciates RM 50 cents per kilometer, okay. If a car depreciates RM 50 cents per kilometer, 50% 1 kilometer, and let's say the car drives about 10,000 kilometers. Okay, calculate what is the depreciation? Who can answer?
It's 5,000, sir.
How you got it? 50 cents times the
This
Sepuluh
times
ribu.
10,000.
Yeah, so you're getting half of the 10,000 is 5,000. So very good, fantastic. Okay, let me just give you one more. Is the method good for office chairs?
Mm, maybe no, because it's hard to track. Better to use straight line.
Yes, fantastic. So difficult because it is not chess is not based on a unit. Chess is just chess, not producing anything. We are
Mm-hmm.
using chess. Okay, great, fantastic discussion. Anyways, okay, now let me just give you a homework before you take a break. You can take down this homework. Maybe you can do it, and then you can post it in the Moodle or something.
Okay.
Or maybe you can also email me, or you can also question me during the no, discussion, online discussion or forum or whatever. So, but I want you guys to try this question. So take down the question. Uh,
Okay.
let's say I give you find a machine. Okay, find a machine. Hang on, 1 minute. Okay, so find a machine or tool used by someone you know. Okay, you can look for somebody, find a machine or vehicle, maybe a car or motorcycle or any tools, any tools used by someone that you know, maybe your uncle or brother or sister or cousin, somebody, and you try to estimate, try this project, estimate how long it used each year. Okay, berapa tahun digunakan, and then try to apply the units of production formula or method. Okay, and if you can bring your numbers to the class. Okay.
Okay.
Right.
Uh,
Yeah.
I'll ask my cousin because why, sir? He owns a bakery, so maybe she have a mixer and oven, so I can ask her.
Great. Great. So we will move on to the next section. So meanwhile, we can take a short break for about 5 minutes. How long you need? 5 or 10 minutes?
Give me 10 minutes, sir.
Okay, maybe you can take a short break for you to digest. Then do some preparation for the subsequent topic of discussion. The subsequent topic is on the hypothesis testing. I'm going to randomly ask you questions. So while
Mm-hmm.
you take a short break digesting, I want you guys to prepare, quickly go through the themes and other materials
Mm-hmm.
of the chapter,
Mm-hmm.
hypothesis testing. Then I'm going to ask you a few questions. Okay, let us take 10 minutes now from now. Yeah. Okay.
Okay, thank you, sir.
Can we continue?
Yes, sir, can.
Okay. So I think we shall continue with the hypothesis testing. I think you have just gone through the chapter.
Mm-hmm.
So basically, we are stepping into the world of statistics here, where decisions are made using the data, not just gut feelings. When it comes to hypothesis testing, database, data-driven. So our focus is on the basic principles of hypothesis testing. Yeah.
Okay, so it sounds serious. So what is hypothesis? It's like a guess, is it?
A good start. In statistics, a hypothesis is a claim. It's a claim or an assumption about a population parameter, like the average height of students or maybe a defect rate in the factory. So now, let's say, let me just give you an example, a real life example for you to be clear about the hypothesis testing. Let's say a company claims their energy drink keeps you awake for 6 hours, and you are skeptical. So you test it with 40 people. So there's a claim that, okay, an energy drink, okay, it will make you to stay awake for 6 hours, and then you don't believe it. It's claiming like this, but we have to test the claim. All right. So now we test the claim with 40 people, for example. So in this situation, what is the hypothesis made for? Okay. Okay. So you collect data to see whether to support or to reject the claim. Okay, so the hypothesis here, we can say that energy drink do not keep you awake for 6 hours. That will be the null hypothesis. Whereas the alternative hypothesis will be, uh, uh, yes, this energy drink do keep you awake for 6 hours. So now we need to follow steps. We have 5 steps of hypothesis testing. Or 4 steps. Some textbooks they use 5 steps of hypothesis testing, and some they used to say about 4 steps. So now let us just make it short. We show it in 4 steps. So the first step is stating the hypothesis. You have the null hypothesis and also the alternative hypothesis. So every hypothesis starts with the true statement, okay, which is the null, H0, H0 or H null, we call it, null hypothesis. Whether the null hypothesis normally is talking about the status quo and the default claim. For example, the average is 6 hours. Okay? And the alternative, it says what we suspect or want to prove. The average is not 6 hours, not 6 hours, right? Got it? Can you follow the first step?
Yes.
So we are testing if the company's claim holds up or not. Okay. So H0 is the company's claim. H1 is your challenge claim. Now step 2, basically, you can even take down or you can see them in the scene. Step 2 is to collect the data and analyze it. Okay, analyze the data. So next we can collect a sample, maybe about 40 people. 40 people try the drink. They have tried the drink, and we calculate the
So your line is lagging, sir.
mean
Sir,
how
cannot hear
long
you.
they have stayed awake. Can you, can you hear me?
Sir, cannot
Lisa,
hear
can
you.
you hear me? Hello, can you hear me?
Okay, now can.
So I was talking about the step number 2. So the
Okay.
step number 2, we have to collect and analyze the data. So we collect a sample of about 40 people who tried the drink. and we calculate the sample mean. We calculate the sample mean, then we run the test statistic. So normally we use the Z-test statistic or the T-test statistic to see how different the sample result from the claimed value. So that is on the step 2 to collect the data and analyze. Step 3, for us to make a decision using a p-value. We can use decision using a p-value or a critical value. So now we look at the p-value and which tells us how likely it is to get our sample result if the null hypothesis is true. Okay, for example, if the p-value, you probably would have seen the p-value in the sim. That is the p of some videos also. The pre-record videos. If the p-value is small, which is typically less than 5%, we reject the null hypothesis. We reject the null hypothesis. Whereas if the p-value is large, greater than the null hypothesis, then we do not reject the null hypothesis, or we do not, or we can say we fail to reject the null hypothesis. So we accept the null hypothesis.
It's like
Yes.
saying that this result is so unlikely, so I don't believe the claim anymore.
Precisely. You reject the null when the result is too extreme to be due to a chance. So now I will go on with the step 4. Step 4 is drawing a conclusion where we do not say the null hypothesis is definitely false, just that the data gives a strong evidence against it. Okay? So any questions? Is there Enigma? Do you have any questions? Can you hear me?
Is step 4, right, sir? Okay, so what
Yeah,
if the p-value is high?
Then we don't reject it. We say there's not enough evidence. We have insufficient or lack of evidence to go against the claim. Okay. So let me just summarize it, just wrap up you. So step 1, we take 4 steps. So step 1 is stating the null and alternative hypotheses. Step 2, to collect the data and compute the test statistic. Step 3, to compare the p-value to significance level, alpha. And also step 4, the final step is to decide, making a decision, jumping into the conclusion whether to reject the null hypothesis or to not reject the null hypothesis. So now let me just give you a practice scenario. You can take down the null and hypothesis, the alternative hypothesis. Maybe we can say we can take down. So let's say a school says students sleep for 7 hours a night. Let's say a school is telling students sleep 7 hours every night, one night. Okay, you think it's lesser than, you believe that it should be lesser than the students are not sleeping for 7 hours. They're sleeping for lesser than 7 hours. So now you can take down the null and alternative hypothesis. The null hypothesis H0 is equal to the mean, the population mean, or you can use the symbol mu. You can put the symbol mu equals to 7. That is the statement that the school state given us. Okay, the alternative that we are challenging the statement, the claim from the school. We are challenging the claim by stating the null alternative hypothesis. Alternative hypothesis H1 or HA. Normally we can see the H1 or HA is lesser than. You can put lesser than 7. So we want to test these two hypotheses, which one is supported, which is not supported. So basically we are testing the null hypothesis. Then what you do, you collect a sample. Let's say the average is 6.5 hours with a small p-value. So if it is 6.5 hours, small p-value. So what can we do, Lisa? Any idea?
So since the p-value is small, we reject the
null hypothesis.
The null, yes, the null.
Null hypothesis. Exactly, you are right. Okay, you have the statistical evidence. Students sleep less than 7 hours. So let me just talk to you about the common mistakes to avoid. Okay. So don't say accepting null hypothesis. We should say we fail to reject. So we are testing the null. So failing, we fail to reject. That's the right way. And also a small p-value means evidence against the null hypothesis, not a proof. It is not a proof yet, but it is an evidence. Evidence against the null hypothesis, and always relate the conclusions back to the real world claim. You have to go back to the you have to go back to the you conclude based on the real world statement claim flow. So now let me just conduct a rapid fire review. Okay. So are you guys ready?
Yes.
Okay, great. So now the first question here, what are the two types of hypotheses?
Is a null, hypoth, and alternative.
Great, correct answer. So next, what do we do when the p-value is less than 5% or 0.05?
We reject the null hypoth.
Hypothesis, correct. We reject the H0 or the null hypothesis, correct. Okay, now we go into another one. Can we prove the null hypothesis or the H0 is true?
No, sir. We can only say we don't have enough evidence against it.
Correct. So yeah, you're totally right. Well, we cannot prove it, but we can only say that we do not have enough evidence to evidence against the null hypothesis. Yeah. So now one more question. One question. So what is a p-value?
The p-value is probability of getting our sample result by null hypoth is true.
Right. That's right. That's right. Fantastic. You're doing very well. So now let me just give you the maybe a homework challenge kind of a thing. What you have to, okay, what can you experiment at home or what can you do at home? Okay, so design your own hypothesis test. Maybe picking something simple, maybe something like boys, you can take down, boys spend more time on video games than girls, something like this, or uh, uh, or maybe like students, you can take down. I mean, you can take down the statement. It's a very simple thing. Or maybe like students from class A score higher than class B. Students uh, from one class, maybe you use class A and class B. Two different classes. They are doing a comparison. So students from class A score higher than class B. And with this, okay, with these two statements, what can you do is you can come up with a null and alternative hypothesis and establish the null and alternative hypothesis. Then uh, come up with how you would collect the data. How would you collect the data, and what will be your conclusion might be? Okay, what's your conclusion might be?
Oh, so if like this, I can ask about the screen time across the classes, sir.
Sorry, Lisa, can you speak a bit louder?
So if this homework challenge, I can ask about the screen time across the classes.
Oh, can. Yes, yes, great. You can do that. Or you can also check if morning students sleep more hours than afternoon students. Anything. Uh, so yeah, I think with this we will move into the next section on the hypothesis testing. So what can we do is we can talk about the types of errors, type 1 and type 2 errors, hypothesis testing, and what it means to make a mistake in hypothesis testing. Yeah. So now let us just go into how to use hypothesis testing to test mean or proportion before that. Okay. So now we are going on hands-on. Hands-on, we shall learn how to test a population mean or proportion. So, do you have any question before we go further?
Okay, sir. Actually, we are going to run the numbers now, is it?
Exactly. Yeah, we are there. You are there. So step by step, we'll start with the testing the mean, then we will follow, we will continue with the proportion. So now we start with the testing, population mean. Okay, now let me ask you some questions on the population mean. Imagine a company claims their battery lasts for 10 hours on average. You can take down. Imagine a company claims their battery lasts for 10 hours on average. So you suspect it's lesser than 10 hours. Okay, so what you do, you take a sample. You take a sample of 36 batteries. Get it down. The question is, by taking sample of 36 batteries, okay, and the average comes out to 9.5 hours. 9.5 hours, and with a standard deviation of 1.8 hours. Okay, I repeat. A company claims their battery lasts for 10 hours. Let's say a company claims battery for less than 10 hours on average. You suspecting it to be lesser. Okay, that means you are suspecting it to be lesser than that. You are assuming you take a sample of 36 batteries. Okay? A sample of 36 batteries, and the average comes out is 9 point. The sample mean is X bar. The sample mean comes out about 9.5 hours. So you got a standard deviation. I give you a standard deviation. Standard deviation is equal to 1.8 hours. Okay, let us just test the significance at alpha is equal to 5%, alpha 0.05 or 5%. So what do we do here is, let me just explain to you step one. So step one, what we do is we say the mean equals to 10 hours. Okay? The population mean. So we need to have the H0, H1 or H0, HA. The null hypothesis statement is what? Is the actual claim. Actual claim. So you can say that the mean population of what? The battery lasting for 10 hours. So the real claim. Whereas if you look at the alternative, you can say the battery lasts lesser than 10 hours. The battery lasts lesser. I'm suspecting. I don't believe the claim. So what I do, I write an alternative. I say it can only last less than 10 hours. The mean population of the battery lasting less than 10 hours. So that's how we establish the null and alternative hypothesis. With that, what we do, we compute the test statistic. For this case, we can use the Z-score. Why we use the Z-score? Just because we have the mean, we have the population mean, we have the sample mean, we have the standard deviation, and also we have the number of observation. So the number of observation here is the N is equal to 36. The number of observation is 36 sample, 36 batteries. So with this information, the best testing test statistic that we can use is the Z-score. So with the Z-score, what we can do, we can calculate the Z test statistic. So mean minus the X bar. X bar is the sample mean. Sample mean minus the population mean divided by the standard deviation. Standard deviation divided by the square root of the number of observations. So the standard deviation divided by the square root of the number of observations is what we call as a standard error. It's what we call as a standard error. All right. So you can calculate the standard error separately. You can just take the standard deviation divided by punca kuasa 2 of n. So if you see the punca kuasa 2 of n, okay, so we have 36 lah. Punca kuasa 2 of 36, we get 6.
6.
Square root of 36, we get 6. Because 6 kali 6 or 6 kuasa 2 is 36, 36. So 6. So what we can do is we can take the standard deviation. So 1.8 divided by the 6, we get a standard error. So 1.6 divided by the 36, we get a standard error. So 1.8 is the standard deviation divided by 6, we're getting standard error. The standard error is 0.3. The standard error is 0.3. And the numerator, if you look at the numerator, is the sample mean is 9.5 hours. Right? So that's what I said, 9.5 hours minus the population mean is 10 hours. So what you get? You get negative 1.67. So negative 1.67 is considered as a one-tail test. One-tail test, therefore, the Z value, the critical Z value must be compared with the computed Z value. So the computed Z value we got is about 1.67, but the critical value is 1.645. 645.
So when we calculate this, the value is negative 1.67, which is less than negative 1.645. So we can reject the null
Hypothesis.
hypothesis.
Yes, correct. You're so good. You're so good at getting it. I was a bit worried whether you can follow or not. Exactly. You are totally right. You have shown the statistical evidence that the battery lasts for less than 10 hours here. Fantastic. So I think I'm very confident with your understanding. So now let us summarize the steps for testing the mean. So the first step is, of course, the stating the null and hypothesis, the alternative hypothesis. The second step is to choose the significance level, the alpha. So now you can see the 5 steps of hypothesis. Earlier we discussed about the 4 steps of hypothesis testing. Now it's 5 steps of hypothesis testing. So we have to compute the test statistics, either Z or T. Either Z or T, then we find the critical value, step 4. Step 5, we decide whether to reject or do not reject, whether to reject or fail to reject the null hypothesis here. That will be the decision making, the final step here. So now let us move into the testing proportion. Just we did a calculation on testing the mean. Okay. So the same way, it is exactly the same way of doing, just that the formula is different. Now we will use the percentage. Earlier we didn't use the percentage, we used the means, averages. Now we're using the percentages. So now let me just give you an example of testing a proportion, a percentage. A proportion means paratus of percentage. So let's try a proportion test. Example, let's say example, a political poll claims 60%. A political poll claims 60% support a new policy. Okay, support a new policy. Use survey, you can take down, use survey. So the political 60%, 60% is the proportion. So you survey 100 people, that's a sample. The N is equal to 100 people. And 50 say yes, 50 say yes. Should we believe the 60% claim? Should we believe the 60% claim? So that is a question here. Okay, I repeat, a political poll claims 60% support a new policy. Okay, I repeat, a political poll claims 60% support a new policy. You survey, you survey 100 people. You survey 100 people and 50 say yes. Should we believe the claim? 60%. You see, the proportion that we collected is 50 over 100, 50%. But the claim is for 60%. So what we do, first step is we establish the null and alternative hypothesis. Your survey is you already start testing, collecting the data and analyzing the data. Okay, step 1, stating the hypothesis. The null hypothesis, you can say the P. In this case, we don't use the mean. We don't use it's not a mean here for proportion, percentage. So this lowercase, a small p, p equals to 0.6. 0.6 is 60%. P is not equal to 0.6. So it is, you see, sama dengan tidak sama is considered a two-tailed test. Lebih besar, lebih kecil is considered one-tailed test. So we are using a two-tailed test because it's equal, not equal to. Case. We can just know it by just looking at the hypotheses over here. So now we do the step two. Step two, we compute for the Z for proportion. For proportion, we can use the Z test statistic. We've got a formula for that as well. So what we can do is we can take the estimated. We can use this formula. If you look at the formula, Z is equals to Z, P proportion hat. But hat, the proportion will have. You look at the scene that you just gone through. You look at the scene, you can see the P hat at the top P. The P at the top P. That is estimated value. The P hat is, for your case, is what you get 50 of them say yes. So your estimation is 50 of them say, that means the proportion that you have estimated is 50 per 100 orang. 50 out of 100 people say yes. So that means your proportion is 50%. The claims proportion is 60%. So the N is equal to 100 people. Okay, so it's very easy. So what you do is you take the estimated proportion minus the population proportion divided by the square root of what? Population proportion bracket 1 minus the population proportion divided by the number of observations. So you can easily calculate that the Z test statistic. In this case, the estimated proportion will be 0.5. The claims proportion from the claim will be the population proportion. In other words, we can say it's about 60%, 0.6, and the number of observation is 1. So we work it out with that. So 0.6, 1 minus P is 0.4. The balance of 0.6, 0.4 divided by 100. Okay, so if you do the operation, so you may ended up getting negative 2.04. That will be the final answer, since I've already calculated it for this example. So with this step 3 for the two-tailed test. Step 3 is a critical value for two-tailed test at 5% significant level, or alpha is equal to 5%. We have used the critical value for Z score or Z score is 1.96 plus minus because it's a two-tailed test.
Sorry, sir.
So, yeah.
Someone called me.
Oh, I see. It's okay. So we are I was talking about the step 3. Step 3, critical values.
Critical values. Okay.
Yeah. So for a two-tailed test at 5%, the critical value we can get about plus minus 1.96. And our Z is
so our Z just now is how much, sir?
It's 2.04. Negative 2.04.
Negative 2.04. So means that the Z is negative 0.04, which is beyond negative 0.196 just now, right? So we check the null hypothesis.
Exactly. The data suggests the pot might not be 60% after all. So let me just do a recap. Mean versus the proportion side by side. Maybe we do a recap. So now we have to look at the features. Few features that I would like to do a comparison between the two different tests that we've gone through just now. One is the mean test. The other one is the proportion test. So if you look at in terms of parameters, so we were using the mean population or mu for the mean test, whereas for the proportion, we'll be using the P proportion. That is the first thing that we should know, because this will be used for the hypothesis testing. So in other words, for mean test, you have to use the mu, whereas for the proportion test, you have to use the P. So that's the first thing. Second, the formula. The mean formula, the Z test statistic is what? Sample mean minus the population mean divided by the standard error. But for the proportion test, you have to use the right formula where the estimated proportion minus the population proportion divided by the square root of population proportion, times with the 1 minus the population proportion divided by that. So you have to use the proportion Z test statistics formula. Then we use when we have averages. We use mean formula. Then we have the averages, and we use the proportion formula, Z test statistic, a proportion formula when we have percentages and we do not have data. Okay, or it is for the yes or no data, basically yes or no data. And the sample size required is large sample, which is more than 30 observations for us to use the Z test statistics. If not, we have to use the T test. That's why you see earlier, the first example when we look at the mean calculation is the N is equal to 36 now. The N is 36. So, so confirm it is Z. It is normally Z or T if you look at a SIP. So when we use that, whenever you have more than 30 observations, we can use that Z test. If you have less than 30 observations, we have used a T test. The same thing for a proportion test. Whenever you have the second example, you can see 100 orang. You survey 100 orang. So you usually need about more than 30 observations to achieve a normality, normal distribution. The sample must be in research when in statistics, the sample must be more than 30 observations for you to have a normal distribution, normally distributed. If not, it's not normally distributed, normally can be rejected. So now we see wrap up discussion. Okay, now these are what did we learn?
Okay. We have learned how to test the real world claims by using the hypothesis testing, and then we separate the formulas by mean and proportion.
Excellent, excellent, clear. Always remember to set the hypotheses, use the correct formula for correct cases, compare the Z-test statistic with the critical value. Finally, we should be able to decide them logically. So now let me give you homework. Before we go for a short break, we will take about a short break for you to digest the first section. After the discussion, we will take a short break. So now, before the short break, you take this down. Maybe you can keep it as a homework for you, for both of you. Find a real world claim. Okay, do this exercise. Battery life, or popularity percentage, or maybe school averages. Then what you do, you write. Up to you. A real world claim can be anything. For example, a battery life. Battery life can be one example which we discussed earlier. Maybe the popularity, prime minister's popularity, or maybe superstars popularity, or your own popularity, or whatever, anything. And also the school averages, the test score, the height score, the weight score, average weight, average height, or whatever. So write the null hypothesis and also alternative hypothesis. Okay, write about the data, collect the data and analyze the data and test the data. Okay, can?
Oh, can, sir. Because I look at the test score from the two classes.
Very good, very good. You can check if more than 60% of cousins or someone likes durian or any kind of fruits like that also can. So perfect. Next class, after the break, we will explore into the type 1 and type 2 errors.
Okay.
Especially we're going to look at what will go wrong in testing. So now, let us take a short break for you to prepare for type 1 and type 2 errors. I want you to look at the type 1 and type 2 errors. Do some quick research while you take the break. So I want you to do a quick research. Please do a quick research on type 1 and type 2 errors in hypothesis testing. And how long do you need for you to do a quick research and for you to have a discussion with me?
About 10 minutes, sir.
10 minutes. Okay, go ahead. Take 10 minutes from now. Research. Make sure you properly watch the videos or do some Google search on type 1 and type 2 errors. Yeah. Okay. Thank you.
Okay, thank you, sir.
Shall we?
Yes, sir.
Okay, we shall go on with this understanding type 1 and type 2 errors.
Okay.
So far you have learned to run hypothesis testing already, and
Yeah.
we also can know now how to make decision based on database, data-driven, evidence-based. But what if we make the wrong decision? Okay,
So, so it's like rejecting the null hypothesis when it's actually true.
exactly. That's one kind of mistake. Okay, so we will explore the type 1, type 2 errors. If the two types of errors we can make in the hypothesis testing. So now, firstly, I want you to do a quick review. Now, let us do a quick review. Let's recall the two possible decisions in hypothesis testing.
Mm-hmm.
Okay, the first one is to reject the null hypothesis. The second one is to fail to reject the hypothesis. But reality has only two possibilities. But in reality, we have got two possibilities where the null hypothesis is true and or the null hypothesis can be false.
So, sir, they actually got four combinations.
Yes, let's look at that. So if you look at let me just tell you about the decision matrix. So roughly, we have reality, four different reality. We can say four different realities where H0 is true or the H0 is true. Okay, two truths and two H0 is false or the H0 is false. Okay,
Mm-hmm.
so now decisions. Let me just match the reality with the decisions. Yeah. So if the H0 is true, we reject a decision can be reject the null hypothesis. The H0 is true, but we may tend to fail to reject the null hypothesis. These are the two possibilities. At the same time, when the null is false, we tend to reject the null hypothesis. Or when the H0 or the null hypothesis is false, we fail to reject. Okay, that means these are the four different possibilities. I repeat, I repeat. When the null is true, null is true, null is false, null is false. Okay. When we reject the null is true, is a wrong decision. But if we fail to reject when the null is true, is the correct decision. The other
Mm-hmm.
possibilities will be we reject the null when the null is false.
Mm-hmm.
We fail to reject the null when the null is false. So, so now the correct decision will be uh, when we fail to reject the null when the null is true, and we reject the null when the null is false. Likewise, the type 1 and type 2 errors, the mistakes that we do will be the type 1 and type 2 errors. The type 1 error, okay, will be is when the null is true. Null is true. The type 2 error is when the null is false in reality. Okay, but when the null is true, we reject them is what we call as a type 1 error. I repeat, I repeat, type 1 error precisely means when hypothesis when it is true in reality. The
Mm-hmm.
type 2 error will be is when we fail to reject the wrong null hypothesis in reality. So we are testing. The decision is based on the testing, our approximation, our test. Okay, but we have the reality. Okay, the real scenario. Okay, so this is what we call the type 1 and type 2 error. So now let me go into in detail on the what is a type 1 error. A type 1 error precisely happens when we reject the null when it's actually correct. Okay?
Mm.
So example, let me just give you an example. Let's say a new drug is not better than the old one. Okay. So I repeat, let's say a new drug, a new medicine or new drug, it is not better than the old one. The old one is better. So it means the null hypothesis is true, assuming the null hypothesis is true, but the test make us to think that it is better. So what we did is we wrongly reject the null hypothesis. Yeah?
So reject. Oh, so we believe something is happening when it isn't.
Yes, precisely. It's a false alarm. We have made a wrong decision because of the of chance. So probability of okay. So the probability of type 1 error is alpha equal to alpha. The common value we use is 5%. So now let us look at a real life example of type 1 error. Okay. So let's say let me just give you an example. Let's say the null hypothesis. Null hypothesis. Let's say okay. Let me just give you a scenario. Scenario which will be good. The easiest scenario, the most familiar scenario will be a COVID-19 test. Let's say a COVID-19 test. Let's say the person, null hypothesis sounds like this. The null hypothesis, the person does not have the virus. Okay, in when implementing and when testing for COVID-19, null hypothesis is what the person does not have the virus. Type 1 error is when the test says they do, but they don't. Okay, you got
Okay.
it?
So it's like telling someone they are sick, but they are not.
Yes, exactly,
Mhm.
exactly. You got the point. So now let us move into the a type 2 error. Type 2 error. A type 2 error is the opposite of type 1 error, and it happens when we fail to reject the null hypothesis. But the null hypothesis is actually false. Okay.
Mhm.
So now let me just give you an example. The drug is better, but we say no evidence. No evidence. So what happens is we stick with the null hypothesis.
Mhm.
So therefore, the probability of type 2 error will be beta. And and it is harder to control type 1. Right. So now let us move into the uh, a real life example of type 2 error. Let's go back to the COVID-19 test.
Mhm.
Okay, let's say the null hypothesis, it sounds like this. The person does not have the
Mhm.
virus.
Okay.
Okay. And now the type 2 error happens when the test says they don't, but they actually do. Yeah,
So we actually miss the real issue.
correct. A false negative. It's a dangerous. It is dangerous in medical testing. Yeah?
Mhm.
So now let me just quickly summarize the error types and also what happens and let me just link it a little bit to the real world analogy. Yeah? So we have type 1 error and type 2 error. So that's why we have a type 1 error. Back to my explanation earlier. Type 1 error is alpha. We say alpha.
Mhm.
Alpha means we're talking about rejecting the true null hypothesis. Whereas type
Mhm.
2 error, we're talking about a beta.
Mhm.
Failing to reject what? Failing to reject a false null hypothesis here. Okay,
Mhm.
and the real world analogy for the type 1 error alpha, rejecting the true null hypothesis, false positive, innocent found guilty, innocent actually found to be guilty. We can
Mhm.
say uh, this is the false analogy. Whereas for if you look at the type 2 error, Type 2 error, which is a beta, failing to reject a false hypothesis, a false null hypothesis is a false negative. It's not a false positive like what we look at the type 1 error. It's a false negative where guilty person walks free. Guilty person got released. So now let's discuss how to avoid them both. Okay. So reducing one, unfortunately, reducing one will increase the other one. Okay, it's a bit difficult. For example, lowering alpha, or maybe from 5% to 1%, but becoming more stricter when it comes to testing, more chance of type 2. Whereas if you try to increase the alpha, we become a loser because less type 2, but more chance of type 1 error. So it's not good for us to take the p-value of 0.1% or the p-value of 10%. It's better for us to set 5%. That's why we set alpha is equal to 5%, or sometimes even 1%, depending on how serious the type 1 error can be. Yeah.
So it's a trade-off.
Yes. You balance the risk of false alarms versus the missed detections. Now, with this explanation, here, a good conversation. With this, let us just look at a practice challenge. Okay, so identify the types of errors. So let me just give you a statement. With the statement, you try to say whether it is a type 1 error or a type 2 error. Let me just check your understanding on the type 1, type 2 error. A school says, let's say a school says, a claim from a school. Example, a school says the average exam score is 70. A test wrongly concludes it's different. A test wrongly concludes it's different. Is it a type 1 error or type 2 error?
It's type 1 error.
Correct. Correct answer. It is a type 1 error. It's a type 1 error. So, so another example, let me just think of, okay, maybe a new engine. A new engine is more fuel efficient, but the test fails to show it. Is it a type 1 error or type 2 error?
It's type 2 error.
Correct answer, type 2 error. So now let me go back to the COVID test maybe. Let's say a COVID test falsely say someone is infected. Is it a type 1 or type 2 error?
It's type 1 error.
Yes, it's a type 1 error. Okay, okay, well, maybe another one. Let's say a faulty test says a sick patient is healthy. Type 1 error or type 2?
It's type 2 error, sir.
Excellent. So now, let me just give you maybe a homework task for you to do it later. Okay, write down one example from everyday life where a type 1 and type 2 error can happen.
Okay.
I repeat, write down one example from everyday life where a type 1 or type 2 error could happen, and explain, explain what null hypothesis and alternative hypothesis are. Or you can put it like this: what H0 and H1 are. Okay, that is the first one, number one. Number two, you can say, you can write down, you can explain what the mistake would be. And number three, you can explain about which error it is. Yeah.
So, sir, I will do one about pregnancy test, sir.
Brilliant. Next time we'll cover a power of test, how likely we are to detect a real effect.
Okay.
So now, we shall move into the, let me just discuss with you on the avoiding the pitfalls, in hypothesis testing. Maybe this can be slightly a new area, right? Maybe based on your research, I think based on your study and research that you have done, maybe you can know a little bit about, maybe you can participate on avoiding the pitfalls in hypothesis testing.
Mhm.
So you know how, now you know how to perform hypothesis testing, right? So calculating p-values, and also you can understand the type 1, type 2 errors as well. So avoiding the common pitfalls in hypothesis testing.
So, so it's like mistakes we might make even when the math is right.
Correct. Even your calculations are perfect, a mistake, a wrong interpretation or setup can lead to a wrong conclusion sometimes. So now the first kind of a pitfall, and a common one, the first kind of a pitfall normally that we can see is misunderstanding the p-value. To put it simple, first and most common one is misinterpreting the p-value, or misunderstanding and misinterpreting, where a p-value is not the probability that the null hypothesis is true.
Okay, wait, sir. Okay, so if the p-value is 0.03, that doesn't mean that there's a 3% chance of zero if null is H0 is true.
Yes, yeah. Correct. It means that if we have null hypothesis were true, there are 3% chance of getting result this extreme. So always remember, p-value is all about the data. Yeah, it's not the truth of the hypothesis.
Mm-hmm.
That is the first problem. So the first pitfall. The second is accepting the null hypothesis. The second mistake, like saying we accept the null hypothesis. In statistics, we never accept the null hypothesis. It's supposed to be we fail to reject it or do not reject the hypothesis. Got it?
Then so why not we just say we accept it?
Because failing to reject null hypothesis doesn't prove it's true. It just means that you didn't find enough evidence against it. I hope you got it.
Yes,
Yeah.
sir.
Next, we are moving into, if you look at the third pitfall, so normally we can talk about ignoring the assumptions. So each test, it has got its own assumption. Each test has assumptions. So like assumptions like normality distribution, normal distribution, like Z test, a T test, that we have the normal distribution, and also random sampling, simple random sampling, especially when it comes to probability sampling and independent observations. Independent
Mhm.
observations. Got it?
Okay. Okay. So, sir, if I test exam scores using a t-test, but the data is super skewed, so I might get the wrong result, is it?
Exactly. Always check the assumptions. We have to check the assumptions before trusting the results. Okay, got it. So now we will move into
Okay.
the next pitfall, using the wrong test. The other one is, other common mistake is using the wrong test for your situation. So testing a mean, but using a proportion formula.
Mm-hmm.
That is very obvious, but and also using Z test instead of a T test for small samples. For less than 330 observation, people wrongly use the Z test. By that, it's supposed to be a Z test.
So, we need to match the method to the data.
Absolutely. Okay. Absolutely. We have to ask ourselves, am I testing a mean or proportion most of the time? Before even testing, before even establishing the null and alternative hypothesis, then
Mm-hmm.
ask yourself if the sample size is large enough or small, whether it is n is greater than 30 or lesser than 30. And
Mm-hmm.
also, is the population standard deviation is known or it is unknown.
Mm-hmm.
So if it is known, then you have to use a different test statistic. If
Mm-hmm.
unknown. So normally the standard deviation, the population standard deviation doesn't mean that we won't get that standard deviation. The standard deviation will be there, known for the population standard deviation or sample. The sample. If do not have the population standard deviation, that is considered as unknown. Yeah. So now we will go into the subsequent, the fifth pitfall. Pitfall is what? P-hacking or testing. P-hacking or testing too many hypotheses also. Let's say you test 20 different things, and one gives P is equal to 4% or 0.04. Is it significant? What do you think?
Isn't there a 5% chance of false positive? So in about just now is 20 tests. So in 20 tests will be wrong just by chance.
Exactly. This is what we call p-hacking or data dragging. Dragging. So if you test enough things, something will look significant. Even it is not. Okay, so how to avoid the pitfalls? Firstly, we have to know what it means, probability of data under the null. Or sometimes the second problem we can say is saying accepting a null. Say fail to reject. That's how we can avoid it. Other than that, we can also check for the normality, randomness, and also independence of the data. Wrong tests, to counter wrong tests, we can say we need to identify the correct test for mean proportion and also the sample size. Finally, for p-hacking, we can say set hypotheses before even analyzing, limiting the multiple tests.
Okay.
So, shall we do a quick practice?
Sure, sir.
Practice on the pitfalls that we just discussed.
Okay.
Let me just check your understanding here. Both of you. Okay. Maybe if I say if we didn't reject null, so the drug definitely doesn't work. Is it correct or wrong?
No, it's a mistake, sir. You can't say definitely. Should say no evidence.
Correct. That's right. Very good. So now we will move into the second. Let me just give you another one.
Okay.
Let's say we got P value is equal to 6% as 0.06. So close enough. Let's reject the null hypothesis anyway. Is it correct or wrong?
That's stretching the rules. So we should stick to our alpha level.
Great, correct. So alpha said 5%. Okay,
Yes.
you see 6% is greater than the alpha value. So we shouldn't do that. Okay. If another one, let me just try another one. Great, fantastic. The sample was 5 people, but we use that test statistic. Sample was 5 people, but we use that test statistic.
Oh, okay. So there's a wrong test because they should use the t-test for small samples.
Yes, as long as you got less than 30 observation, we have to use the t or not that. So final reflection. Okay, please remember, hypothesis testing is powerful, but like any tool, it must be used very carefully. And normally, big mistakes happen when we misinterpret the result. And also, we try to skip assumptions or push data to get what we want. We do some manipulation, then we can have this kind of things. Problems. So now, for your assignment, maybe for your homework, what you have to do for this area, I think you should find an article. You can please try to find an article or a news story, but they must report a statistical result. Find a general article or working paper, or maybe some research paper on this area. You see that, or technical papers. Then that you must have the results. Then you can search or ask an adult. maybe you can search or ask somebody, somebody who has got it, or maybe you can even ask me. If you can't find that, let me know. I can even provide. So what you want, what you have to do is, firstly, you have to identify what is the claim from the statistical result. What is the claim? Basically, that's the first thing. Then second, what is the null hypothesis and alternative hypothesis might have been.
Okay.
And then you also need to identify whether any pitfalls are there. So try to get a simple statistical output, statistical result from any articles or any news or anywhere, and try to identify these three things there. What is the claim? What hypotheses are might have been a possible hypothesis, null and alternative hypotheses, and also whether pitfalls are there. Okay, so you can look at the medical research and all that now. Right. So
Okay.
any question?
No, it's okay, sir. I'll check a health article on sugar and weight gain, sir.
Very good. Or you can even find something about the public opinion surveys. Also, you can find the
Oh,
articles.
sure. Okay.
Excellent. Maybe we will wrap it up all with power significant levels and real life application of test in business and science.
Okay.
So okay, maybe we can take a short break. Okay, maybe it's not a break. Maybe we can
Next section, sir.
maybe we can take a short break. Now maybe I think we have another few more minutes here for us to end the session. Anyways,
Okay.
let me just go through the themes with you
Mm-hmm.
on the hypothesis testing. So what are those areas that you have to study? And also the subsequent chapters. For the last session, when we will be meeting for the last session, give me a few minutes.
Okay.
So from the SIM, we have discussed about the basic rules. So far, we have discussed about the basic rules of hypothesis testing and how to use the hypothesis testing mean and proportion. And also we discussed about the pitfalls in hypothesis testing. So ethical issues we still have not covered. So I want in our discussion, basically the synchronous session, we have not discussed this yet. And also maybe one more area on the assumptions. I think we just did a little bit about the assumptions, but we still have to cover this thing. Okay, in two areas, two subsections from the SIG 1.3. You can see all the formulas are already given here.
Yes.
Yeah, on the steps. Even the steps, we have 10 steps here in the SIMs. We can even sometimes can cut it short to 4 steps or 5 steps, whichever is convenient, as long as it is comprehensive. Or we can even stretch up to 10 steps sometimes when it's required, and the rejection area. And I believe you have already seen the self-check one and all that. And watch enough videos or whatever videos, pre-recorded videos that has been embedded in the SIM. So make sure you are going through. So you can see this is what we discussed earlier. Mean and proportion was clearly covered, and I already checked your understanding. You have a very clear understanding about the mean calculation and the 5 steps. 5 steps hypothesis testing, the mean calculation and the proportion calculation is very, very good. It's satisfactory. It's more than satisfactory. So fantastic work. And the formulas also, I believe you have already memorized them. Normally for the final examination or tests, normally for statistics or quantitative methods, we will provide the list of formulas. But whatever it is, I still suggest my students to memorize. As we practice, as we calculate, we must know the formulas. As we know the formulas, then we know where to apply and when to apply exactly. So if we are relying on the formula sheet, then it will be your level of confidence can be questioned or can be affected there. So from my observation, the students who have memorized all the formulas, they are more confident and they score better. They have a better performance compared to those who are not. Okay. So my suggestion is to you can try to memorize the formulas and you can rely on a formula sheet just to check the formula that you have memorized or you have written is correct or not. So just to check. So that will be mainly that's the main purpose of providing the formula sheet during the examination. So you can also look at these activities and look at the 1.3 is the assumptions. So importance of verifying assumptions. So this is what we're going to discuss in our next session. So we must know the steps and all that. And assumptions, the types of tests that we have to use according to the situation. So today's class we have today's session we have discussed about the web test. We have discussed about three tests, but we did not we discussed about ANOVA, chi-square, linear regression, parametric. We did not cover correlation. So next discussion will mainly on the linear regression and also the correlation coefficient. We're going to look at these two chapters, which is the chapter 9 and chapter 10. Chapter 9, we have an entire chapter on the linear regression, and chapter 10 is all wholly about the correlation test. So pitfalls, we just discussed about the pitfalls, but it was not very thorough, but we did discuss about a couple of pitfalls that have been covered. I believe we have already gone through the activities and also the common pitfalls. This diagram also you can see insufficient sample, inadequate test duration, multiple testing, biased results, and so on. Okay. So next, ethical issues is what we have to cover. We have not covered. So this is the second area that you have to prepare for your next discussion. So and also please take enough time. I think you have enough ample of time for our next meeting. Yeah? So before the next meeting, so please make sure you do your self-directed study and watch all the embedded video lessons, and also do all the activities as well as the self-check questions. So make sure you properly do all the self-check questions for the chapter for the simple linear regression. A simple linear regression as well as so for the simple linear regression, you have about only 4 sections. And you can see the brief description of each of the sections. So you can just watch and do all the practices for this particular chapter. Then finally, we'll be also talking about the chapter 10. Hello, can you hear me?
Yes, can hear.
Yeah, and also chapter 10. Let me show you chapter 10.
So next session we will cover chapter 9, chapter 10, is it, sir?
A continuation from chapter 8. Hang on, let me just show you the chapter 9 as well. Chapter 10, sorry. A few more minutes, a couple of minutes. Chapter 10 on the sample correlation. So sample correlation, we only have 3 areas for you to cover. So see whether you can cover up to chapter 10, then we will do the discussion on the chapter 10. So chapter 10, basically, you just need to know what are the correlations and how to calculate the correlation coefficient. The video will teach you. The formulas are all here given here. And also finally, you have to know how to interpret the value of the correlation coefficient. Interpretation, only three areas. So with this, we can just finish the coverage. Okay, so do you have any questions? If no questions, we can end the session for today.
No, no questions, sir.
Okay, thank you for joining. So see you in
Thank you
our
so
next
much,
session.
Mr. Arun.
Thank you.
See you
Thank
next session.
you.